You know how it goes. A project starts out so simple, so clean. But then, as it gets bigger, you add a feature here, a tweak there, and before you know it, you are wrestling with this tangled monster of code. Well, today, we're going to learn the trick that professionals use to untangle that mess for good, right? Does it feel like making just one tiny change over here breaks three different things somewhere else? Like you have to keep the entire program loaded in your brain just to add one little feature? Yeah, that's a classic sign that your code structure, its architecture, is fighting you. But guess what? It really doesn't have to be that way. So we're going to fix this. And we're going to do it by building a professional blueprint before we get lost in the weeds of complex code. We'll use a pretty simple student management system as our example, but the ideas we're talking about today, they apply to literally any project no matter how big or small. This is all about learning to think like an architect, not just a coder. Okay, so what's the secret weapon here? It's not some crazy complex algorithm. It's actually a super simple idea called the single responsibility principle. All it means is that every single piece of your program should have exactly one job. And we're going to build our entire blueprint on this one core idea by dividing our system into three very distinct, very specialized roles. Think about it like this. First, you need something to just hold information, right? Like a student's name and their marks. Second, you need an engine to handle all the rules, to calculate a grade. And third, you need some kind of system to manage the storage, to save that info and get it back later. Each part does one thing, and it does that one thing really well. And here's where it gets cool. We can translate those abstract ideas directly into code. The part that holds the data, that becomes our student class. Our logic engine, we'll call that the student service. And the storage unit, that's our student repository. And just like that, we've created a crystal clear map for our whole application. So how does this neat little blueprint actually turn into a program that runs? Let's take a look. This is where the magic really happens. And you're about to see just how clean and, well, understandable a program can be when each piece just sticks to its one single job. First up, the student class. Honestly, I like to think of this as a digital index card. Its only purpose in its entire existence is to hold information. An ID, a name, some marks. That's it. It has no idea how to calculate a grade. It doesn't know how to save itself to a database. It just holds data. Period. Next, we've got the student service. This is our rules engine. It's kind of the brains of the operation. It takes one of those student objects, looks at its marks, and then applies all the business logic. Does a 75 mean you get a B? Does a 35 mean you fail? The student service is the one that knows all the answers. And finally, we have the student repository. This thing is our filing cabinet. Its entire job is to take those student objects and store them somewhere, and then, go get them when we ask. For now, it's just using a simple list in memory, but the real beauty here is that we could swap this out for a real database or a file system, and nothing else would have to change. All right, let's see how this all works together in a flow. The main program, it kind of acts like the coordinator. It creates a new student. Then it hands that student over to the repository to be stored. Then it asks the service to do all the great calculations. And finally, it presents the results. It's like a clean, predictable assembly line where every single part knows exactly what its role is. So you might be looking at this and thinking, wow, that seems like a lot of different files for a simple program. Why go through all this hassle instead of just dumping everything into one big script? Well, the answer is power, flexibility, and frankly, your own sanity. The payoff here is absolutely huge. Remember that single responsibility principle? This is where it really shines. It creates something we call loose coupling, which is just a fancy way of saying our different parts aren't all tangled together. So if you want to change the grading rules, you only touch the student service. Need to change how you store data? You only touch the student repository. It makes your code an absolute dream to maintain and test. So the real takeaway is this separation. A super common beginner mistake is to stuff the grading logic right inside the student class. But now your simple data holder is also a calculator, and things get messy really, really fast. The professional way is to isolate these jobs. That's what creates a system that's clean, scalable, and honestly, a joy to work on. And this isn't just about making your code clean for today. No, this is about future-proofing your work. You're not just building a program, you're building a foundation that can actually grow and adapt without completely crumbling under the pressure. Because everything is loosely coupled, making massive changes becomes surprisingly simple. You could literally unplug that simple list-based repository and plug in a new one that uses a powerful database, and the student service would never even know the difference. You could build a web interface or a desktop app on top of this exact same logic. The possibilities are pretty much endless. And that right there is the heart of professional design. By not locking your business rules into your storage methods or your data into your user interface, you keep your options open. You're giving your future self the amazing power to adapt to new demands without having to rewrite everything from the ground up. So from now on, remember this. Your code is more than just a set of instructions. It's architecture. And by embracing this simple idea of separating jobs, you can stop writing code that just works and start building systems that actually last. Systems that are robust, adaptable, and truly professional. So the only question left is, what architectural masterpiece will you build next?